This would be considered a fairly easy probability question on the test, but a really good chance to explore, to look at some of the characteristics you want to look for in any probability question. We've got the probability formula written down here. Probability formula, the number of desired outcomes over the number of possible outcomes. You want to think about the denominator first when you see a probability question. How many possible outcomes are there? And here, of course, there are 24. We could select a 1, a 2, a 3, etc. So that's the first point. Think about number of possible outcomes. Second point, each of these outcomes, picking a 1, picking a 5, picking a 12, each of these outcomes is equally likely. So just like flipping a coin, chances of getting a head, 50%, a tail, 50%. Similarly here, the chances of picking any one of these numbers out of a hat, as long as you have your eyes closed, equally likely. Let's take a look at exactly what they're asking for. They want to know the probability of selecting a number that is divisible by 7. So I'll just write div for divisible, div by 7. Plus the probability of selecting a number that's divisible by both 2 and 3. Well, let's talk about that. 15, for example, it's divisible by 3, not 2. 16, divisible by 2, not 3. What's a quick way to figure out which numbers are divisible by both 2 and 3? Well, 2 times 3, of course, is 6. 2 and 3 are factors of 6. So if a number is divisible by 2 and 3, it is also divisible by 6. So what we're really asking for is we want the probability of a number that is divisible by 6. And that, I think, is really the most complicated part of this question. We're going to be adding those probabilities. Numbers divisible by 7, what are they? Well, 7 and multiples of 7. 7, 14, 21, 3 out of 24. And note that when we say 3 over 24, what we're really doing is adding 3 probabilities. Chance of getting a 7 or 1 in 24, a 14, 1 in 24, a 21, 1 in 24. So we're already adding up probabilities. And then we'll add to that the probability of selecting a number divisible by 6. Well, what are those? Those are the multiples of 6. So 6, 12, 18, 24. The chances of selecting a number that's divisible by both 2 and 3. So that's 4 out of 24. And if we add all these up, 7 out of 24 is our answer. So some important qualities of this question. First, the probability of picking any of the numbers is the same as the probability of picking any of the other numbers. In other words, the chances are equally likely. Second, what? We're adding probabilities. And third, you'll note that none of the numbers appeared in both categories. There's no number here that is both divisible by 7 and divisible by 6. So our choices were mutually exclusive. Now, if the numbers on that list were, instead of 1 through 24, if they were 1 through 42, well, 42 is divisible by 7 and it's divisible by 6. So answering that question would take another step. But here, each outcome mutually exclusive, so the answer is 724. And just to really emphasize how important it is to think about the denominator first when you see a probability question. A new slide here. Here are all the possible outcomes, 24 possible outcomes. You can imagine them at the bottom. And then how many desired outcomes? So we have 6, 12, 18, 24. We have those up there. And then, of course, 7, 14, and 21. So that's the best way to really visualize it. Here, of course, it's easy to visualize the numerator and the denominator, but you can also see some really hard probability questions where it's not obvious what the denominator will look like. If you found that helpful, hope you'll go ahead and click the like button, subscribe, and if you have any comments, by all means, post them. We love to see comments, and we'll see you in the next video.